Okay, it is started.
Okay. I think that we can start now.
Okay, okay. Hello everybody. Well, ahora vamos a empezar el segundo día de nuestro meetup de mayo para el público en español que nos está siguiendo en este momento. Como saben, esta es la comunidad del Java User Group en Bolivia. Entonces, estamos con este evento, nuestro meetup de mayo. Hoy día vamos a tener la exposición, una ronda de preguntas. Luego vamos a estar sorteando, bueno, haciendo algunas preguntas por Slido, como lo hicimos ayer. Y vamos a estar preguntándoles también algunas cosas a ustedes para que podamos tener para el sorteo que realizaremos mañana, el último día, con los auspiciantes que tenemos, ¿no? Entonces, ahora tenemos un invitado muy especial hoy día. Tenemos al lead de Amazon Corretto, que ya les va a estar explicando de qué se trata, una alternativa al JDK de Oracle que tenemos, y vamos a estar viendo este tema, que es básicamente el tema de los lambdas en AWS, la migración de JDK 8 al JDK 11. Entonces, voy a hacer switch al inglés para presentar a nuestro expositor. Espero que esta exposición sea de mucha ayuda para todos nosotros. Vayan preparando sus preguntas. Va a ser vía Slido, que ya la organización del Java User Group Bolivia está posteando en nuestras distintas redes sociales. So let's start. Gisai, Ken, thanks for accept this request to have this presentation as a part of the talks that we have every month in the Java User Group Bolivia. We started like 5 months ago this new Java User Group, and well, it's very grateful to have this presentation from people from Amazon in order to know about Corretto, in order to know about what you are doing. So thank you again, and we can start.
Well, thanks for the invite. I'm pretty sad that I have to do it from my home in Redmond, in Washington, next to Seattle, and not from Bolivia, because I always wanted to visit. But this is a good start. So my name is Ishai. I'm the general manager for Amazon Corretto. Amazon Corretto, we'll talk about that in a second, is an OpenJDK distribution from Amazon. And today I want to talk about why you want to migrate, if you're still on Java 8 or older, to Java 11, why it's easy, and why there's a lot of value for you when you run your service or your application. Specifically, I'm going to talk about AWS Lambda and how AWS Lambda, the service, is running on Java. And this is the story of how we migrated it from Java 8 to Java 11, how we did it, what we measured along the way, and what are the results. So I'll start by introducing Corretto. I'll talk about Lambda's architecture and metrics, a little bit about Java 11, and beyond that, how we made the updates, how does the deployment and rollout look like, and what did we learn, and what were the results. So we start from Corretto. Amazon Corretto is a downstream distribution of OpenJDK. Some reason looks like my screen is not changing. There we go. So it's a downstream binary distribution of OpenJDK. OpenJDK is a project, obviously started by Oracle, but now managed 2 ways. There is the tip that's still run by Oracle, and then there's the Java 8 and Java 11 that is currently managed by Red Hat. And Corretto is a downstream binary distribution from these projects. We provide a no-cost long-term support for Java 8 and Java 11. We release at least once a quarter. That means if you need Java, you can use it as replacement for any other hotspot-based distribution. and there is no cost associated. There's no license. There's no support agreement. We really ask you for nothing in return for using it. We also called it Amazon Corretto and not AWS Corretto. It's quite important. It's something that anyone use. It is not tied to AWS. You can use it on your computer, in your data center, and of course on AWS or any other cloud that you might want to use it in. It is multi-platform. We run on various types of Linux, Windows, Mac OS. We have Docker images. We support x86, and lately we started supporting AArch64, coupled to the release a few days ago of the Graviton 2 processor in AWS that lets you run big workloads extremely effectively in AWS. You can find us in the links below on the left side. aws.amazon.com/Corretto is our homepage, and the project is developed on GitHub under, obviously, the GPL v2 with class path exception license in the Corretto organizations, and we have multiple projects in there. In terms of support schedule, we support Corretto 8 at least until 2023. There's discussion starting in the industry around extending that date, something we're still discussing. Corretto 11 at least until 2024. And as of now, Corretto is the default Java if you're using Amazon Linux 2, or if you run Java workloads on AWS Lambda, they're all running Corretto by default. One thing to remember is all of Amazon services are running on Corretto. So Amazon is a big Java shop. A lot of our services are built in Java. So if you ever shopped on Amazon.com, or if you run services on AWS or use Alexa, almost anything in Amazon will have Corretto in it, in the stack. So moving forward, I want to talk about the release cadence. So LTS releases have about 5-year lifespan. And with Java 8 and Java, you can see the light blue lines that show the extended support that we're providing. And similarly, we plan to do the same for Java 17. The non-LTS versions have about 6 months of lifetime with about a month overlap for security patches. And in our experience, for anything big that you build, it turns out that many customers are not ready to update the Java version that quickly. So it makes it hard for a lot of customers to pick Java 12 or Java 13, even though it has a lot more features and a lot of updates. It turns out that not many customers are able to run Java 14 in production and have that stay secure by patching from Java 14 to Java 15 in these about 4 weeks of time. So hence we're focusing for now on Java 8 and Java 11, where we see most of our customers running both internally and externally. This is a product that we released. It's called the Amazon Corretto Crypto Provider. So regardless if you're using OpenJDK, our OpenJDK, namely Corretto, if you're using Oracle JDK or any other distribution, we released this package. It's in Maven Central. It's called Software Amazon Crypto Tools, Amazon Corretto Crypto Provider. I know it's a long name. But the result of that, if you use it on Java 8, you can see below in the graphs. Memory consumption on the left side of the graph is what the process used to do before we installed the crypto provider, on the right side afterwards. So for workload heavy crypto operations, like SSL termination, like computing hashes, like creating secure randoms, these operations are quite expensive, and the Corretto Crypto Provider provides you an easy way to reduce that load and save money and run the same load with less machines, or have the machine run a lot cooler, giving you more headroom to throw more work at the machine. We've been using the crypto provider in Amazon, and we released it in January 2020 on Maven Center, or the latest release in 2020. Netflix is a company that chose to adopt ACCP, and they're running it on thousands of cloud instances, both Lambda instances, EV Cache, and their TLS. It was very easy to integrate. When we met there, we were able to get to a proof of concept within the first hour, where we just came in prepared to present it and talk about it. But by the end of the hour, we had a proof of concept working, and eventually Netflix decided to adopt it in their systems. Similar, more and more workloads are testing and vetting Corretto. Example, Micronaut. It's a micro framework for Java. Has announced that they're supporting Amazon Corretto, both on Amazon Linux and Corretto separately from that. The good news in this is every time we went to do one of these certifications or testing, we've seen that there's nothing really different. Corretto is a distribution that is drop-in compatible. The big thing that we do is we provide support, patches, answering questions, basically free of charge. We like to learn about things that are not working for you or could be done faster, because when we fix them, we make the rest of us happy, make our internal projects work better, and it's a win-win for everyone. So at this point, I want to move on and talk about the Lambda architecture. So we're going to put it aside for a little bit and talk about how Lambda takes requests and routes them. I'm seeing that the update on the screen is going pretty slow, so I'm going to jump quickly through all the animation and try to walk you through what's happening. So you can see the user on the left side. This would be you, for example. You deploy the Lambda function and you want to call it. Lambda is a service that lets you run Java code without worrying about scale, without worrying about infrastructure, without worrying about load balancing or availability. I'm assuming that many of you have already given it a try. So in this case, the user takes a Lambda function they already deployed and wants to invoke it to a certain region within the AWS cloud, typically within an availability zone. The first thing it's going to hit is an application load balancer. After that, it's going to hit the Lambda front-end service. And the front-end service has a few responsibilities. The first one is to find a worker. There'll be another machine that runs your code. So it talks to the worker manager. It finds a machine where your code can run on. If it needs to scale and have more machines because you have a lot of traffic, you'll get more machines. And after it negotiated that, it's going to invoke your function on the worker, wait for it to finish the work, and then send you the results back through the front end back into your caller. Your caller can be on your desktop, in your data center, or another service you deployed in AWS, or even another Lambda function. One thing that we see is in this service that we talked about, the front-end service, is that the time it takes to process your request is additive to the time your function is running. So if the invoke overhead takes X milliseconds and your function takes Y millisecond, what you observe as overall latency on the client side is X plus Y. So when we started this project, we measured invoked overhead, and we measured the P50. P50 is what 50% of the calls are faster than. And then the next thing, remember Lambda runs billions of operations per day, and we want to be able to make all of our customers happy. So P50 means half our customers are getting worse results. So the next thing we look at is P99. As you can see, P99 is a much higher value than the P50. And if we keep pushing the P39s, or that would be 1 out of 1,000 calls, we'll see even a higher latency. And if we push to 49s, you see it goes up a little bit, but not that crazy. Theoretically, we want to make the P100 better, but P100 graphs tend to show additional effects that are not interesting for this talk. So in this talk, I'm going to focus on P4 to P50 latency. We always look in Amazon at how do we improve operations and security. And in this case, we looked at latency and we said we want to get it down, further down. So one of the first things you look at in Java, so we drew a graph of GCPs with their open. So what you can see in this graph is from P1, so 1% of the not latency, sorry, pause. So this is the shortest pause, or the 1 percentile pause, 50 milliseconds. The 4.9 pause is 140 milliseconds. Now, please keep in mind that these don't translate to latency directly, because what you're missing in this graph is the frequency. So the P49s may happen once an hour, right? Where the P1 may happen once every 5 minutes. That doesn't mean the P1 request directly translates to the GC pause, but we have a good indication of some work we can do to look at this. It's a big, complicated system, probably one of the biggest systems in the world, and we say, what can we do here? So one thing we can do is we at it. Reduce the latency because there's less load on every one of these machines. But at the same time, the price or the cost to operate is going to go higher. And one of the other things we strive to do is keep lowering our prices every year. We want to get it down so it's cheap and easy for you customers to run Lambda functions. So we also want to look at the efficiency of each host. And the only way to do that effectively is to measure. If we start guessing and start throwing code changes at the system, it's really hard to tell what actually, where the impact came from. So the first thing we did is we went and worked on adding additional measurements. So this is the first measurement we added. It's called heap memory after GC. And what that measure is, and we have a separate discussion here on the bottom of the slide, you can see the Corretto 8 pull request that will show you how to use, how to create that yourself. It's a metric math that you can do with JMX metrics. We made some fixes in Java that enables this metric to work, but what it does is it tells you after the collector has run and collected enough memory, how much memory is actually being used by the system. So it separates the transient memory from the relative percentile occupancy in the JDK you're running. So when we looked at it, again, if you look at the percentiles, we took the P50 to the P100. This time, the percentile doesn't represent requests, they represent hosts or machines. So 50% of the machines running the Lambda frontend were using 18% of memory or less. And the worst machine out of all of them, the P100 machine, was using 23% of memory. The memory variation can happen because different machines may see different mix of customers or type of requests, but the spread here is very low. We're looking at 5% difference. This is not too bad, and machines that are using 20 to 23% memory are not expected to suffer from adverse GC effects. So we didn't find anything truly interesting here, and we moved on. The next thing we start to look at is measuring the application allocation. This is a standard JDK flag, or Java flag that we introduce in almost all of our services. And what we do is we print the GC details, we log them. We always rotate the log file. And we have a few log files, in this case 4. And then we limit the log file size to 10 megabytes. So we have about 40 megabytes of GC log files on disk. If something happens, one of them gets corrupted, we always have 3 others that we can pick. We also debug incorrect that in edge cases, writing GC and having heavy I/O to disk might create a side effect of a stop the world pause. But we have fixed that so it's safe to run these in Corretto, and eventually it will be safe in all OpenJDK distros. So what did we see here? We look at the results. We're using the G1 collector, as you can see here, G1 evacuation pause. And we see that we allocate 11.7 gigabytes over 5.5 seconds. So we have a 2.1 gigabyte allocation rate. This is a significant allocation rate, but not alarmingly high again. So it's something that when I see it, I'm saying, system is fine, but can I do better? If I can, I want to do better. So the next thing we wanted to do is measure the allocation rate per request. And with that, we can measure a unit of work that is scale independent. We can find regression in the user code, and we can measure the impact of any code improvement we make. I'm not seeing this updating. I'm going to wait a second.
Yes, now we can see.
Yeah, so actually jumped one over. So there you go. So this is a piece of code that we added to the app. And basically the code is quite simple. We call it the allocation stopwatch. And what you do is at the beginning of the operation, you create the MX bean, the thread MX bean, you get thread allocated bytes, and then you get, so you capture initial bytes, and then at the end, you do it again, you do A minus B, and you get how many bytes were allocated on that thread during that operation. If you're using a mechanism that use the thread pools and hop over threads, you have them in Kotlin, you have them in Java, you need to write a little more complex code that I'm not going to get into here. And again, what we found here is that this mechanism wasn't very effective, because if you have an app with a lot of threads, it was pretty expensive to get that data. So initially we used sampling, but as you can see on the bottom in Corretto, we made an improvement that made that the cost of making these calls insignificant, and now we can run these at 100% of our operations. So now what you can see is, again, back to our percentiles, the P10, or the cheapest request, or almost the cheapest request, was using 700 kilobytes, or the most expensive request was using 1400 kilobytes per invoke. So now we have a baseline, and we know what our code is doing. So we're going back to the next question, and we don't know what to do. So we kind of pulled on our Lord of the Rings references, and as Bilbo said, we always want to move forward and see how we can change the world. So we're moving to JDK 11, which is the main reason we started this discussion today. So JDK 11 is the next long-term supported version of the JDK 8. JDK 8 is still the most popular of Java out there, but we believe JDK 11 is more than ready for production. We're using it effectively in many services in Amazon today. And I want to talk about the journey of moving Lambda over to it. So there's a lot of new features in Java 11. So sorry, it doesn't flip that fast, but you have flight recorder, you have low overhead heap profiling, HTTP client, you can type var, and all kinds of cool things. But in this talk, I just want to talk about what if you don't have to code in Java 11 and all you have to do is take your Java 8 app and flip the JDK to 11s. What happens then? So first, G1G is now the default collector. It has better ergonomic behavior over Java 8. The full GC is parallelized, and overall it works a lot better. As usual, there's always caveats to that, and we keep finding small things, us and others, of course. And you're going to see continuous stream of patches and improvements in G1. The other thing, which I think is probably the most interesting thing, is the compact string representation. It's a small feature, but what it does is for Latin strings, it reduces the footprint for the heap. So what does that mean? Strings are generally Unicode, which means they take 2 bytes each, right? And it turns out that most of the strings in Java applications are not localized. So this is great if your strings are localized and you write in languages that are not Latin languages. But it turned out when you look at Java processes, a lot of the strings are identifiers or plainly the app is in English. And if you just go to JDK 11 and you do absolutely nothing, we're seeing that the heap size of strings, the part of the heap that's utilized by strings, can be reduced by roughly 50%. And generally, we can see 30% reduction across the whole heap. An investment like that will take you a much, much, much longer time than just flipping the Java version. So in Java 8, the word Amazon will be represented with 0A, 0M, 0A, and so on. But in Java 11, there will be a coder that says this string is Latin, and then you just have Amazon as a byte. So you have 7 bytes instead of 12 bytes in memory. And the longer the string, obviously, the more effective this becomes. I want to take a quick detour. Even in Java 8, there was a feature called use string deduplication. There's a JVM flag that lets you do it. I suggest that if you're still on Java 8, you haven't decided if you want to go to Java 11, give this a try. You run Java with -XX plus use string deduplication. You must be using the G1GC. Measure your memory before and after. If your memory has been reduced significantly, you're probably a good candidate to go to Java 11. And if you have seen this reduction, you can also capture a heap dump. Like you can use the Eclipse memory analyzer, find the duplicates, figure out where they came from, and go fix them. Particularly if you find something in a shared library you're using across multiple projects, that'll be a great thing to fix. We did try this flag, and our latency actually went up. We found that we had a lot of duplicated strings. Our memory consumption went down, but because of coupling between this feature and other things in the JVM, locks and things like that, the latency actually went up. So good thing to use in a pinch if you don't worry about latency and you're running out of memory. But you have a much better chance by just going to JDK 11. So let the upgrade. How did the upgrade go? First, we just went to our desktop. Or it wasn't me, it was a developer on the Lambda team. Updated Java version for the front-end invoke service, didn't change the code, didn't recompile, start, run all the tests, everything worked just fine. That was it. That was about, I don't know, 30 minutes of work, and they were in Java 11. However, as they started working, they started to merge into repository, things didn't work anymore. And one of the first things we encountered is that Java 11 doesn't have the same API, set of APIs that Java 8 has. For example, JAXP is no longer a part of Java 11, but it turned out pretty easy. All we had to do is add that Maven dependency, and the problem went away, and we were happily continuing to merge. So when we look overall at application code changes, we had to find the right version of JAX-B. We had to update log4j to the latest version, at the time at least, and we had to upgrade Lombok to 1.18.8. And service worked again. The situation was complicated when it came to tests because we were running older versions of Mockito and older version of ByteBuddy. So I'll talk about that in a second. The tests were broken, a lot of them. What I wanted you to do is keep your dependencies up to date, update your of libraries or bases, because when this happens, you might be stuck. We also wrote a lot of test code with Mockito 1.1, where we could have done that work on Mockito 2.2.5, and then we wouldn't have that extra delay in moving to JDK 11. So I'll show you what differences we've seen. So one example was the matcher for nulls. For a string, you type when mock method any string, then return results. That didn't work anymore, and we had to change when mock method nullable string class instead, when the value was null. And while this seems like a trivial change, if you have this in hundreds or thousands of tests, then you have hundreds of thousands of things to change. And sometimes you can do it with a find and replace, and sometimes you can't. So that takes time. Another one, this is actually a good improvement in Mockito. So we had an index that says it will throw an IO exception. However, the implementation was not throwing an IO exception. That's completely valid in Java. However, when we wrote the test in mocking phase, we mocked the implementation to throw an IO exception class. And Mockito 1.1 said, fine, I'll let you do that. And Mockito 2 said, nope, I can tell you that this implementation will never throw an exception, so I'm not going to allow you to run the test, to write the test. And the test broke, even the code didn't break. We had to go fix the test. So again, the messaging is keep your tests dependencies up to date. They're just as important as your code. Code dependencies up to date. And when these updates, other updates are coming along, you have a setup that just makes it easy for you to move on. But just like I'll show you the value of the Java 11, when you update other dependencies, they typically, not always, but typically run more efficiently and fast because we have a big open source community that cares deeply about performance, and they keep improving their libraries, and you get free work for so many good people that are investing in open source. Why wouldn't you take it? At this point, we're done. It wasn't a big investment. It was mostly fixing test code and updating dependencies, but it took all that. And then, if you remember, at the time, at least, AWS had 20 with 69 availability zones. We have a lot of customers that are depending on Lambda. While the change, we wanted to make sure that when we launch, not breaking any customers. Now, of course, you write tests, you write integration tests, and you have a lot of in place. But as soon as something hits production, there's always a chance that something will go wrong. And very careful to do these rollouts that will have the least impact on customers and be the easiest to roll back if something happens. So I'll talk you through what our rollout pipeline look like. So you have a build, we have these test stages that I was speaking about. And then we go to our first region. And how do we choose a region? The first region, we typically choose a smaller region with less customers. So if something really bad goes on, we impacted a few customers and not a lot of them. When we're done with the first one, we move to the second one that has more customers, and then we move on from there. Inside that first region, we do first and then a fractional deployment and then production, which means every customer sees that. So even within that one region where there's less customers, we still move carefully and slowly. This is, by the way, how we release every single release regardless if it's a JDK 11 or a single line change in the code. So let's dive deeply into region 1. So the first change we do is staging. What happens in staging is we have a few servers that get the new production code, and they talk to a few, you can say, customer entries in the database. These are test entries. They don't impact the customer. But what happens at the same time now, we have production code that talks and tests against this parts of the database. So what happens here is if the staging code creates, say, bad data that the old code cannot read, or the other way around, the staging data cannot read code that the production code is writing, we're worried about a situation called a poison pill, and we will roll back the deployment and delete the test entries because they mean nothing. It's not real customer data. So we send test traffic both to staging and to production from a third system to make sure that we can exercise all these combinations. Then the next stage is we move to fractional. Fractional means now we're hitting some of the customers. So X% could be X% of production servers, X% of customers. And now at this point, we're hitting real customer data. Still only a small set of customers and not all of them. When enough time has passed and enough tests have passed, production tests and production, we promoted, and now we're working against the full region or the full availability zone within. And by the way, last thing is when I say database, necessarily mean a SQL database. Oftentimes this is something like DB, and no SQL database that can scale to our needs in a service as big as Lambda. And I'm seeing my slides are not updated yet. I'm going to wait a second here. I'm still not updating, so I'll let you know. What happens next is everything turns yellow, and database turns yellow. So now we're done. We rolled out to a small region. We monitored. We observed the larger region. And why are we doing all that stuff here? The first is unknown unknowns. So JDK has a lot of new APIs. And everything in this fine, we still don't know that every single edge case in the system is going to continue working as it was. The other thing is latency, especially in a big code change like that. Some things only gets discovered 2 or 3 or 4 weeks later. Some cache somewhere is starting to fill up and it doesn't get cleared, but it's very slow trickle, and over a month of operation, you might find things. So in this rollout, while we have a fully automated system, we slow down and we move more quickly to build confidence and to make sure we don't break our customers. So we only went to 2 regions at the beginning, and only after we're happy with a large region and a small region, we moved on to standard automated rollout. So what was the results? Bugs, customer impact, rollbacks, nothing. I mean, no news really, and no news in this case in deployments is good news. But from the pilot deployments, we had a lot of valuable data about how things work, and we built confidence. And in August 2019, we rolled it out across the world, and now our customers enjoy a faster invoke. And we started working on next improvements, and there have been quite a few improvements since. And we have a very fruitful relationship between the Corretto team and the Lambda team. We generally look at them as customers, just like we look at you as customers. They come to us and say, hey, can you do this? Can you make this change here? We found this bug here. Go and make the change, contribute it to OpenJDK, release it internally in Corretto. Everybody enjoys these improvements over time. So since August 2019, I can't have data to share here, but numerous additional improvements to the Lambda invoke speed. And the pattern is the pattern that I recommend everybody use: measure, improve, and then repeat and do it again. Most important things we learned is a JDK 11 uses memory, and if you reduce memory consumption, or allocations are not free in Java, they're very efficient, but when you allocate on the heap, overall your latency will go up. So I want to show you some graphs, but I'm waiting for
maybe some questions. Carlos, do we have a question?
Yeah, absolutely. While we're waiting.
Let's see the chat, please. Okay, Antonio says, do you have some benchmarks? For example, Corretto versus Oracle versus OpenJDK or another implementations?
Yeah, so what I want to say is OpenJDK and Corretto are one and the same. So while we had benchmarks in the past, we're finding that the value of Corretto is not that it's faster than anything else, or that, the project is one, OpenJDK is one project. All we're doing in Corretto is listening to your feedback and fixing things, other performance, or bug fixes, or hard to diagnose crashes that's been sitting around for a long time. Because we run Corretto on a lot, I can't say how many servers, but it's a very high number of servers, and we can observe these servers. We can catch things that are very hard to catch in a local environment to reproduce items. But everything we almost immediately contribute. So whatever benchmark I give you today, in 3 months, you're going to see the same, or 6 months, you're going to see the same improvement in OpenJDK itself. So there's some value that we can show you with Amazon Corretto Crypto Provider, because it is unique and it cannot be merged into OpenJDK. It's a standalone Maven library. But for Corretto itself, the whole idea is that you will get the same thing from OpenJDK as well. Or there's no really a thing called OpenJDK. It's a project, but other distro, these things just flow through between the distros, and we're not competing on performance. Again, the key value we provide is support at no cost, and the ability to observe things in a really big and diverse set of applications in production that I don't know that other distributions have the ability to see that. But again, every time we do that, it just goes back to everybody else as well. So this is a open source community effort. So I want to jump to the graphs real quick, and then we can take more questions. So what we can see here is the allocation rate reduction after the deployment for Java 11. You can see where the line is on roughly August 14. And what you can see is the P50 or the P1 haven't gone down. It's down a little bit, but not much. It's clear on the P50, and it's extremely clear on the P99 request, right? We went down from 3,100 kilobytes to roughly 2,200 kilobytes per request. That's okay, but what's the result? There's much more full reduction in the GC pauses. So remember, the 140 millisecond pause went down to 5 at the 4 nines, and the P50 pause went down to 20 milliseconds. We attribute that partly to the G1 collector improvements, and partly, if not mostly, to the memory allocation reduction. And these are the results. Unfortunately, I can't show you the millisecond latency, but I can show you the reduction in percent. So the invoke overhead at P99 went down by 20% just by this change. At P99.9, even better, it went down by 40%. At P99 or 4.9s, it only went down by 30%, which the graph should update here in a second. And that told us that the latency in the 4.9 were partly G and partly from downstream services like the workers on the graph. And it told us where we need to work on next. So while we can make more improvements here, we can go to the next downstream service and make improvements there to reduce the latency overall. To summarize, what did we learn today? Number one, if you want to take one thing from this, is keep your dependencies up to date. It's going to pay you dividends. It's a lot cheaper than writing the code yourself. And you're going to stay secure, and your code is going to run better generally. However, to do that, you'll be in a shape if you use continuous integration and continuous deployment, deploy your service, because updating your code and updating your dependencies may introduce bugs over time. And a robust D process can catch these things before they hit customer, or if they hit customers, knows how to roll them back quickly and effectively. Last JDK 11 here, it's been here since 2018. It's more than ready for prime time. I wrote this last year in November, so we're 5-6 months past the time I wrote this. I don't see a reason. If you write new code, definitely go to JDK 11. If you're running on Java 8, the cost to try it out less than a day, and you can convince yourself very easily that it's an investment to do. Deploying large changes requires a little extra thought and pragmatism. Think about how you're deploying it, how you make changes, how you're controlling what we call blast radius, even if you're using continuous integration and continuous deployments. And the last thing is Corretto is powering Amazon services, it's powering Lambda. You should give it a try as well.
Okay, great. I think we can go with the questions. Julio, could you help us, please?
Yes. Okay, it says how different is Corretto from OpenJDK in terms of features or libraries? I'm assuming that it has security patches and improvements in performance.
Yes, so Corretto does not have a difference in security. Security work is done by most of the vendors. I think at this point, almost all of them are part of the security update. We work together months ahead of the release to make sure all security patches are aligned. So every quarter, you get the same security patches from all the major vendors, Oracle, Red Hat, us, Azul, and so on. When it comes to performance and bug fixes, sometimes we prefer to, depending on how critical that is, we prefer to go to OpenJDK, contribute to OpenJDK, and then let it flow back into Corretto. Sometimes, let's say you're a customer and you have a production problem and you can't wait for 3 months, we will make the patch immediately, release it, and then go and contribute it to OpenJDK. Some patches happen very quickly and get accepted in weeks. Some patches, have taken over a year to get accepted. There's a lot of discussion, and eventually they come in. Might see patches show up a little bit later. We have a good example. We have one right now that is around how to make measurements of memory, like the heap memory after use that I showed earlier, streamlined, and that patch has been taken over a year now. But it's something we're working in, work with the community, getting it, and eventually it will get.
Very nice. Antonio says, can I use Corretto in Docker containers for free?
So the answer is yes. In terms of if you want to use it or not, of course, you got to look at your legal team and so on. We don't put any limitations on Corretto. The only license that comes with it is the GPL v2 with class path exception, and that's it. We have Docker images on Docker Hub, and we also have them in an ECR container with on AWS. If you run on AWS and you want to pull from ECR, you can pull from there. You want to build your own Docker image, you can do that. If you want to start with the Docker Hub image, we have that as well.
Okay. This has the same question. Can I develop using OpenJDK and then migrate to Corretto? That's a yes, right?
Yes.
Another, when should I use AWS Lambda versus Amazon EC2?
So Lambda is a service that works great if you don't want to handle building servers, maintaining them, patching them, and the work that comes with launching instances. Generally recommend that if your workload fits Lambda, run it on Lambda. There are limits, Lambda, like the amount of runtime and the amount of that you can upload, and at some point, that will not work for you. The type of workload that you use. I would add that in between Lambda and EC2, there's another interesting layer. And my team builds Corretto, but also I have 3 other teams at AWS services. And we're using a mix of, depending on when we do the service, of Lambda and a product called ECS Gate. And that is a managed way to run Docker containers with a scaling backend that will provision EC2 for you. That's Fargate. Or ECS, you have to bring your own EC2 instances, but you can still run containers and have all the rest. Of course, you can always use EKS, which is the Kubernetes equivalent. And ECS and EKS serve a similar idea. I personally, in my services, prefer ECS and Fargate because I don't have to worry about the rest of the Kubernetes stuff. But if you want to build, if you've chosen Kubernetes, then EKS is your solution there. So 3 layers, Lambda, EKS, ECS, Fargate, and EC2 would be the smallest, the most simplest building block, but also the most work you have to do around.
Okay. Next question. How is the performance with big heaps? For example, 8 gigabytes, 12 gigabytes. Maybe he has monolith, right?
Yeah, so the performance of Corretto in big heaps is exactly the same as the performance in hotspot. There is no difference. We have customers using it, and I think when you go to big heaps, things become interesting. And think about what is the latency that you care about, what parameters. We talked to you about that. We're spending a lot of time with teams using big heaps, much bigger gigabytes. 12 is kind of a normal number I see every day. Nothing unusual. But again, depending what latency you're trying to achieve. The general recommendation we give teams that work in that space and care about latency is Java 11. Use more heap than less. Your service needs, about and you have 10 available gigabytes, 10 gigabytes. And the other thing is, don't try to tweak G1. It typically does it better than you. Very rare. I've seen an example like that, but it's extremely rare that we actually have to tweak settings for G1 better than how we did without.
Okay, nice. The last question. I think he or she is a student, is an anonymous message, is asking about Java. How can we compare Java with Node.js in terms of speed and performance, and if Java is dead? Every year,
Okay.
year dead, no?
So, interesting question. So first, what I've seen is, I'll talk in very, very much general. What I've seen is that Node startup a little bit faster than Java. So your time to get hello world in Node would be faster than in Java. But when you're trying to write a heavy load, Java, from what I've seen, and this is super general, is about 30% more efficient. So if you run one machine and you're doing a small project and you're serving, 5 requests per second, I mean, whatever, use what you feel comfortable with. But if you get to the point that you run, say, 100 machines, and that cost starts to be very impactful, Java will be about 30% faster than Node. Not to mention that Java is type safe, and Node could be use TypeScript, and last, I mean, it's a big discussion that I'm definitely not going to be the final judge on. My teams are building services, both tools for various reasons, and every service, makes its own decision. Mostly, though, we do build in Java. Do I think Java is dead? It's absolutely not dead. The JVM, I think, is one of the best runtimes available out there. If you don't like Java, you have Kotlin. If you don't like Kotlin, you have Scala. It's an amazing ecosystem with so many options and opportunities. I mean, you can run JavaScript on the JVM as well. So, yeah, definitely I don't see Java dead or even remotely close to that.
Yes. Okay. Which operating system or which characteristics of an environment does we need to get more performance with Corretto? Maybe is asking, or she is anonymous, about if Corretto runs better in a flavor of Linux or maybe Windows. I don't know.
I think that so I don't have good information on that. And Corretto runs exactly as in Java and Linux, and past experience, by the way, is in Microsoft on ASP. And on Linux and Windows, and these two chasing each other. So whatever I'm going to tell you today is going to be different, in 6 months. I think the most important to an operating system is what you're comfortable with, other tools you need on the operating system beyond just the runtime. You run Java on Windows for a service for very, very specific reasons, and mostly I see Java on Linux.
Okay. And the last one, what restrictions apply to AWS Lambda functions code?
What restrictions?
Do you have restrictions?
I'm not sure I understand the question. Would you mind repeating it or maybe clarifying it?
Maybe he or she is trying to know if you have some restrictions on code. Maybe some code that is using too much resources. I don't know. Something like that, maybe.
So there are limits in Lambda. If you go to AWS Lambda, there are very specific things that, there's a runtime that's limit. How long can the function run, and how much memory you need to transfer, and how much storage you have. But these are all detailed, and how much memory you can allocate. but they vary by the level of the Lambda you choose. I suggest just going to AWS and looking it up. I'll also be happy to help if you have more specific questions. My contact is right there on the screen. Feel free to shoot me an email or tweet at me, and I can help you with more specific answers to your specific problems.
Okay, we don't have more questions in Slido.
Okay.
I don't know if you guys have.
Yeah, maybe some of you.
No,
well,
a great presentation.
Okay. Well, if there is no more, I think. Well, Gisai, I have to tell you that the first talk that we did to as a kickoff of this Java user group, we tried to well, we have an example with Java using different mechanisms of cache, memcache, for example, and we basically in that point we said, okay, let's use Corretto. We get the container from Docker Hub that was using Corretto, and we ran that example with that container. So since that time, we were trying to contact the Corretto team with Amazon, and well, I think we can do. We did it now, and well, I think for the community and also for the Java user group, it was all this talk that was very helpful. So thank you for your presentation. Also thank you to Ken in order to, because he helped us to organize all of this contact. So I think we will try to keep this channel as long as you have time also to hope to have more talks and so on.
Sounds good. I appreciate it. I need to start another meeting in 5 minutes, but I want to thank everybody for coming and listening, and feel free, my email and my DM open. I can introduce you to other people in the team. As usual, we're hiring people. If you're a JVM expert, talk to us. If you want to use Corretto, talk to us. If you have general Java questions, we're happy to help.
Okay, thank you, Gisai, and well, from the organization team also of the Java user group, thanks for your time, and we will keep in contact. Thank you.
Thank you. Bye-bye.
Thank you. Say bye.
Bye-bye. Thank you, Gisai.
Bye-bye.